circuits. Do you remember this demo? So in this demonstration, there's a potential difference between the two terminals of the battery. That's always true. The wire is a conductor, and so it will allow current to flow when the path is completed. So the two ends of the wire that are at the two terminals must be at a potential difference because the terminals of the battery are. So a current flows, but that energy has to be dissipated throughout the circuit somehow. Since there's no resistance really in that wire, there's very little, it turns into heat and light, and therefore gives you the dramatic display. So what I really did in that demonstration was created a short circuit. So current is like physicists. It's kind of lazy. So a short circuit is a path with extremely low resistance relative to the rest of the circuit that allows a very high current to flow. This high current is what makes a short circuit dangerous in electronics or machinery. If you have a very high current, you're going to get a lot of thermal energy coming off, which can melt wires and start electrical fires. This is what a short circuit looks like in a diagram. Electric current is going to follow the path of least resistance. So if you have this switch and you close it, okay, the switch has much less resistance than the light bulb. So you're going to get a short circuit. Now, because there's still a path for electrons to flow through the rest of the circuit, you will actually get a very minimal amount through the rest of it. However, it's basically minimal, and that's why you can't really see the light bulb light up anymore. Most of that current is going through the short-circuited wire. A closed or a complete circuit really only has two requirements. In order for any current to ever flow, there must be a voltage source. Remember, this really is a delta V, but we write this as V if we're going to quantify it in our circuit, and that's going to be the same as your battery. The circuits you were working with in class today were 1.5 volts for their voltage source, same as a D-cell battery. The unit is still volts, remember, just like we've seen. The other requirement is at least one complete path of conducting material. This is what you experimented with at the beginning of class today. So these diagrams should look relatively familiar from what you did. Okay, if you have an open circuit, which is a not closed circuit, there's a voltage source here on the left, but there's not a complete path of conducting material. Air doesn't really conduct electricity, thank goodness. Now, in the middle picture, there's the closed circuit, the switch is closed, so it's a complete circuit. There's a voltage source and a path for the current to flow from high potential to low potential. So what we played with today in class are called knife blade switches, just because of their shape, and so you can use those to open and close circuits or parts of circuits. In a simple circuit, which is all we're going to be working with in AP Physics 1, there's only a few parts, which we call elements. You need a battery or a power supply, something to provide that voltage source. You need wires to connect the elements together, or some other conducting path. You need lamps, lights, light bulbs, resistors. So you may not actually have a circuit that creates light if you had entirely resistors. That's okay. And you can have a switch, although it's not required. Here is what these different elements would look like in a circuit diagram, which you saw briefly in class today. So you can also draw a light as just a resistor with a circle around it. A circuit diagram is just a schematic drawing of the circuit components. So a schematic drawing just means it's kind of an outline. It doesn't actually represent what in real life the wires look like. It just shows you how the circuit goes together, and it makes it easier to see the overall picture. So here's a circuit diagram. You actually made this circuit today in class. So here's the voltage source. Now here, there's a short line and a long line. Please note that the long line is the higher potential, so it's the positive terminal of a battery. The switch is here. The light functions as a resistor here. Remember, in a simple circuit, you need to have at least one resistor. It doesn't have to be a light, but you need to have a resistor. And then you have the wires which connect the other elements, and usually we make all of these drawn with the right angles, just so when you start adding more elements, say extra resistors, it's easier to figure out what's going on.